Hi, this is Brandon Baines in the Math Department at Lipscomb University, here to talk with you today about finding x-intercepts and y-intercepts of quadratic functions. In this presentation, you'll learn how to find x-intercepts and y-intercepts of quadratic functions using equations and also using graphs. You'll recall from App 2, we defined the x-intercept and y-intercept. We restate those here. The x-intercept is the point or points where the graph of a function crosses the x-axis. And you'll remember from App 2 that all of the y values on the x-axis are 0. And so anytime we have an x-intercept, it will be an ordered pair of the form x, 0. The y-intercept is the point where the graph of a crosses the y-axis. Since all of the x values on the y-axis are 0, then all y-intercepts will have ordered pairs of the form 0, y. When looking at a quadratic function and finding the x-intercepts using the equation, this will often require us to solve a quadratic equation. If it's been a while since you've solved a quadratic equation, you might want to go to the prerequisite materials and watch some of the videos for using the quadratic formula. Let's consider the example of finding the x-intercepts for the function f of x equals x squared minus 5x plus 4. Just like we did in App 2, we'll let y equal 0. When we do that, we have the equation 0 is equal to x squared minus 5x plus 4. I'm going to factor x squared minus 5x plus 4, and I get x minus 4 times x minus 1. And this implies that either x minus 4 is 0 or x minus 1 is 0. This implication is here because this is a multiplication statement between the two factors x minus 4 and x minus 1, and that product is equal to 0. So it must be that one of the factors is 0. This is known as the zero product property. Solving for x in each of these cases, we have x equals 4 or x equals 1. Both of those x values make this equation true. And so both of these x values are solutions to that equation. Pairing them back up with their y values, we have the ordered pair 4, 0 and the ordered pair 1, 0 as our x-intercepts. There are also electronic ways of solving these equations. You can use a graphing calculator or Wolfram Alpha to solve this kind of equation. To find the y-intercept using equations, we will let the x value be 0. This results in a bit of a simpler calculation than finding the x-intercepts. Consider the function f of x equals x squared minus 5x plus 4. Letting x equal 0, we find f of 0 to equal 0 squared minus 5 times 0 plus 4, which is 4. You'll notice that that's the value of c in our general definition of a quadratic function, f of x equals ax squared plus bx plus c. This is not a coincidence. The y-intercept is c for all of the quadratic functions. Provided an xy table that has enough points on it, we could identify those intercepts using that table. Consider the function f of x equals negative x squared plus 4x minus 3. And we could look at the xy table below for that function. We see the y-intercept here as the ordered pair 0, -3. And we see the ordered pair 1, 0 as an x-intercept. And we see the ordered pair 3, 0 as an x-intercept. But just as we said in app 2, sometimes the XY table may not have those intercepts on there, especially if the intercepts turn out to be a fraction or a decimal of some sort. And so we may have to go back to solving an equation. If we plot these ordered pairs and construct a graph, we can identify the intercepts on the graph. And we see here the y-axis, and this graph crosses the y-axis at -3, 0. We'll see here the x-axis, and this graph crosses the x-axis at the ordered pair 1, 0, as well as the ordered pair 3, 0. A few notes of caution when using graphs or tables to calculate the intercepts. In particular, with the x-intercept, we should be aware that some quadratic functions do not have x-intercepts. For example, the graph below will never cross the x-axis. As you see, it's a parabola opening upward. And so it will not have x-intercept. If you try to solve for them using the equation, you will not get a solution. You could search the XY table over and over. You will not find any ordered pairs that satisfy the definition of x-intercept. Second note of caution is that sometimes our intercepts have fractional values or decimals. And so if constructing an XY table and plotting the graph, we just may not see that. For example, here, this x-intercept, we can tell that it's somewhere in between 2/10 and 3/10, but not really sure exactly the value, so it's hard to determine. So in that case, we'll have to go back to solving an equation or using some electronic method to find the intercepts.